Hey everybody, welcome back. Proportions and similar triangles are going to be discussed today. We are going to move on to 7.5. We have 2 lessons left in chapter 7. Let's go. Okay, we're going to be talking about a couple of different theorems, both the regular and the converse theorem of the triangle proportionality theorem. All right. Which means it leads us to our very first theorem today. So please pause now and write it down. It says, if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. Okay, so if you notice, on this triangle, you will notice AE is over BE or EB. So this side, the top half of that line, okay, is going to be over, and it's almost like it creates a fraction here, over this bottom section. Okay, notice we have AE over EB. And this line is almost that divider. Kind of gives you where that fraction would end up being. Same thing on the other side. Okay, you have AF right there. Oop, you can't even see that color. How about this? AF over FC, which is this bottom part here. Okay, notice again that line here gives you that kind of splits it up and helps it make a fraction easier. Okay, let's give the first one a shot. Okay, it says find SU. We are trying to find SU. That's this segment right here. Okay, so automatically it tells me that I have two parallel lines, right? UV and ST are going to be parallel. And we know that according to that triangle proportionality theorem, if those are parallel, then we have a proportional triangle. So how do we set that up? Well, we look at RV over VT. Okay, again, I'm using this parallel line kind of as my breaking point. And I have RV on top, I have VT on bottom, and that's going to be equal to RU over SU. Are you going to get this problem right? I hope so. Okay, so now when we look at this, we plug in the numbers that we know. We know RV is 10. We know VT is 4. We also know RU is 14. And SU, we're not sure what SU is. So because we do not know SU, we're just going to plug in our variable of x. From here, how do you solve a proportion? Cross multiply. Cross multiply is correct. And you get 10x is equal to 56. And now we're just trying to find x, right? Because x represents SU. So we're going to divide by 10 on each side. And x is going to be 5.6. And I'm done. So what is SU equal? SU is equal to 5.6. Don't be afraid if you get a decimal, because you're going to get several decimals today. Don't worry about it. Just make sure you're setting it up correctly. If you set it up correctly, you get the correct answer. All right? I want you to try the next one on your own. Give this one a shot. Okay, you are going to be finding FG. F, not 5. You are finding FG today. All right, give it a shot. All right, when you look at this, you have to set up a proportion first. And remember, according to that triangle proportionality theorem, okay, because we have those two lines parallel, okay, that allows us to create a proportion. Okay, so now we're going to create a proportion of FH over HE over he, and FJ over JG. Okay, because of that, we now can plug in what we know. All right, so we know what FH is, which is 20. We know what HE is, which is 30. We also know FJ, which is 11. However, we do not know JG. This right here, we don't know that. So because of that, we plug in X as our variable. Okay, how do you figure out a proportion? I'm not even going to wait for a response because you should know it is going to be 20x is equal to 330. Remember, cross multiplication. You divide here by by 20, and x is going to equal 16.5. All right, we found JG. Are we done? No, the question asks us to find FG. So all we do, we take that 16.5 and we're going to add it to FJ, which is 11, and my overall answer FG is going to equal 27.5. Remember, that's the entire length here. The entire length of this side is FG. Okay, and that's going to be, because this is 16.5, we add those both sides together and we get 27.5. Done! Moving on. Okay, now we have this converse. We've talked about the regular triangle proportionality theorem. Now it's the converse. So pause now, write this theorem down. All right? So when you look at this, it says if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So now, before we had if there's a line parallel to a side, then the triangle is proportional. Now, if we have the triangle is proportionally divided, then we have a line that is parallel. Okay, so it's, again, the opposite. So let's try one. It says, given the diagram, determine whether DE is parallel to BC. And we do that when we set up our proportion. If it is proportional, okay, then it is going to be parallel. And explain, that's going to be your theorem. So what I want you to do right now is I want you to try to see if you can figure out if this is, if these two lines, DE is going to be parallel to BC. Find that out. Give it a shot. All right, let's see how you set up your proportion. If you look at this, you are going to have AE over EC, and if it is proportional, it should be equal to AD over DB. Okay, so you now have 8 over 12 is equal to 10 over 15. Okay, is that true? Well, let's cross multiply. Let's check it out. Cross multiply, 8 times 15 is 120, 10 times 12 is 120. So are they equal? Yes, they are. So are they proportional? Yes, they are. What does that mean about our lines? They have to be parallel. How are they parallel? Through the theorem, that converse of proportionality, or of triangle proportionality theorem. Okay, so you show your work. And you do need to show your work, and you do need, this is your explanation right here. When it says explain, make sure you write down the theorem that it goes along with. Okay? So show your work, then show your explanation. Fantastic. Okay? The next thing that I want you to know is the mid-segment of a triangle. So pause now. I want you to write this all down. Okay? Do you need to have the drawing? Absolutely. Do you need to have this little thing on the side? Yes, you do. Please write it down. Thank you. All right. So if you look at a mid-segment of a triangle, mid-segment is a segment that joins the midpoints of two sides of the triangle. Okay, so XY is going to be a mid-segment. However, it says every triangle has 3 mid-segments. Well, it has 3 sides, so it has to have 3 mid-segments to connect all 3 sides. It says which form the mid-segment triangle. That inside triangle, you will notice, is going to be triangle XYZ. That's not the big deal, okay, but you do need to know what a mid-segment is, because with the mid-segment, you're going to have a theorem, all right? So pause now if you haven't finished, because we're going to move on. Okay, because a triangle mid-segment theorem, it states, and yes, please write this down, a mid-segment of a triangle is parallel to a side of the triangle and its length is half the length of that side. Okay, so not only do we know that DE is parallel to AC, not only do we know that DB is congruent to AD and BE is congruent to EC, but we also know that DE is half of that AC. Okay? So just by knowing that triangle mid-segment theorem, we know a lot of information is given to us if I tell you this is a triangle mid-segment. Okay? So based on that mid-segment, we have a lot of information. Okay? Let's try one. So now it says find the value of n. Okay? Now, what information do we know about this triangle that helps us figure this out? Well, we see right here, you'll see the segments that these two sides are congruent and that these two sides are congruent, which means this point right here and this point right here has to be the midpoints of their given sides. What does that tell us? Well, if there's a segment that connects those two midpoints, that means that is a mid-segment. Okay, so now we have a mid-segment there. Now, do you remember how to set that up? Okay, that's the question. Look back in your notes, and I want you to try to see if you can set this equation up to figure out what n would be. So try to figure out an equation. All right, so now when you set that equation up, remember, that mid-segment is going to be half of the original segment. So here's our mid-segment right here. Here's our original, kind of the base of it, of our triangle, okay, or the original side of a triangle. We know that n plus 14 has to be half of 3n plus 12. Be careful, you do need these parentheses because you're not just taking half of 3n, but you're also taking half of that 12. You're taking half of the entire segment. So from here, you know how to solve. Distribute this 1/2 through. Okay. And then you solve for n. Bring your numbers together. Bring your letters together. And you're going to end up with your n. Okay, whoops. 3 over 2n. Okay, now we have to subtract this n from both sides. Then we get 8 is equal to 1/2 n. How do you get rid of that 1/2? Well, it's multiplying, which means we have to divide by half, which means we're multiplying it by its reciprocal. In other words, we're multiplying it by 2. And we get n is equal to 16. Okay, and we're set to go. We're done. We figured out what n is. The question asks for what is the value of n, and we found n. All right, so do you know, in this video, do you know what the triangle proportionality theorem is? Do you know the converse of that triangle proportionality theorem? Okay, do you know mid-segments? Can you come up with a proportion to make that triangle parallel? And if you have parallel lines, can you come up with a proportion to find that missing segment? Okay, that's what you just learned in this video. Those are the questions you need to ask yourself. Be prepared for the homework later on. Have a wonderful day.